The best way to study is to take practice tests. And if you can't find good practice tests, build your own and learn while you do it using the Learn My Test study tool. It's absolutely free at learnmytest.com. And check the description, the link in the description, to take a practice test that I made using the Learn My Test tool. So today we're going to talk about correlations. So correlations look at relationships between two variables, variable one and variable two. And the correlation coefficient is called a Pearson R, which ranges from -1 to +1. Values that are closer to -1 indicate stronger negative correlations, whereas values closer to +1 indicate stronger positive correlations. So you may be asking, well, what is a positive correlation and what is a negative correlation? What are you talking about? So let's go ahead and answer those questions. So a positive correlation means when variable one goes up and when variable one goes up, variable two goes up. And when variable one goes down, variable two goes down. They go in the same direction. Here's a great example. So the more you exercise, the longer you are likely to live. The less you exercise, the shorter you're likely to live, right? So as cardiovascular exercise increases, life expectancy increases. As cardiovascular exercise decreases, life expectancy decreases. Okay, let's take a look at a negative correlation. So cigarette smoking, right? The more you smoke, the shorter you're likely to live. So as cigarette smoking increases, life expectancy decreases. But at the same token, the less you smoke, the longer you're likely to live. So as smoking goes down, life expectancy increases. They go in opposite directions. When one goes up, the other goes down. That's a negative correlation. And like I said, the closer you are to -1, the stronger the negative correlation is. Okay. So there's not just a positive and negative correlations. There could be things that don't correlate at all. So, for example, on the Sundays that I, wear my Lucky Luke Kuechly jersey, and I made this a while ago because now Luke Kuechly's retired, but I'm a huge Carolina Panthers fan. The more likely they are or they're no more likely to win a game when I wear the jersey. Even though I think it may have an effect on the game, the reality is it doesn't. So when one thing happens and it has no effect on the other thing, it has no correlation. And values that are closer to 0 are indicative of that these two variables are not really correlated. So a big problem that we have in research is that we tend to take stuff that's correlations. Like we say, okay, this variable goes up and this one goes up. And we think, oh, because this one goes up and this one goes up, this one causes this one. And that's not necessarily true. Just because one goes up and the other goes up, or one goes up and the other goes down, doesn't mean that that thing is causing it. It just means that when this one goes up, this one goes up. So let me give you an example of where this can get a little bit dangerous. So this is a great example, ice cream sales and drowning deaths, right? So when ice cream sales increase, drowning deaths increase, okay? When ice cream sales go down, drowning deaths go down. So does that mean when I take my wife's ice cream and I decide I'm going to eat this whole pint of my wife's Denali Moose Tracks, that I'm going to now all of a sudden have an increased risk of drowning in a lake? Even if I have no intention of going swimming at all today, if I eat this ice cream, it means I'm going to die. I could die of drowning. I'm increasing my risk of drowning. Even if I've never swam in my life ever, me eating this is going to increase my risk of drowning. Even if I've never touched water before, eating ice cream is causing me to drown. Like if I eat an ice cream, of course, that's not true, right? That is not true, right? Um, I tried to drive home the point to say that just because when ice cream sales go up and drowning deaths go up, that doesn't mean that when you eat an ice cream cone, you're more likely to drown, or that the ice cream cone is suddenly, adding cinder blocks tied to your legs when you jump in a pool and you're going to drown, right? The reason that they're both related is that this one goes up and this one goes up is because of hot weather, right? When it's hot out, people are more likely to buy ice cream. And when there's drowning deaths, people are also more likely to swim when it's hot out. And so, of course, they're more likely to drown. So that explains these two the relationship between these two variables. And so I drive this point home to say that correlation does not mean causation. So just because one variable goes up and the other goes up does not mean that this variable causes this one. So in your research papers, you want to be very careful about using the word cause. You don't want to use the word cause when you have a correlational study. You want to say there's a relationship between this variable. This variable affects this variable, but nothing about, oh, this causes this. That's a very, very, very strong word in research to say one thing causes the other.